Oh.
Hi guys, welcome to God Academy. In this lesson, I'll be taking I'll be taking you through some series of differential equation problems, and these are going to be quite advanced problems. So take glued to your seats, and if this is the first time that you are joining us, kindly do us a favor by subscribing to this channel and make sure you share to your friends as well. So this is the first problem that I'll be taking you through, and it's under systems of equations, which is second order differential equations. So the problem says write the following fourth order differential equation as a system of first order linear differential equations. So we have a differential equation. Okay, this one is higher order, I would say, not necessarily second order. So higher order differential equation. And we have y prime 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 prime. That is the fourth derivative plus 3y prime prime minus sine t multiplying y prime plus 8y is equal to t squared. So I have a series of initial value, initial conditions here, right? So y of 0 is 1, prime of 0 is 4. So you are supposed to break this down into a systems of linear equation. That is an approach for us to solve any differential equation of, higher orders, right? So far as you are dealing with ordinary differential equations, you can simply break your differential equations different simple first order, then you just apply matrices to solve your differential equations, as simple as that. So let's see how we tackle this. So this one is a straightforward problem. The question is not asking us necessarily to solve it, but we are going to use the systems of equation. We are just breaking it down into the general systems of equation. For you to express any differential equation as a systems of first order differential equation, it follows a general rule that we have x prime, right, which is a vector, right? S prime is equal to a matrix, which is a coefficient matrix, multiplying x, right, plus g of t. So now the g of t part is simply the non-homogeneous part, okay? So if you have a homogeneous higher order differential equation, you realize that this part will be zero. Okay, so let's break our higher order here into the different steps. So first of all, we normally express our y's into what x. Okay, so the x are new variables we introduce in solving this problem. So let's see how we can do this. So the first thing you do is you let x1 be equal to you let s1 be equal to y. Okay, we want to convert all our um y's and our derivatives into systems of first order. So we assume an x1 for our y. Then again, what you do is if I'm to differentiate both sides, what do I get? I get x prime, that the x1 prime is equal to y prime. Is that not it? Yes, so this is upon my first differential. So when I differentiate it this way, I will equate this to x2. So now I can say that my x2 will be equal to y prime. And this is another equation. So the first one is my first equation. This becomes my second equation, okay? Now, when I differentiate my second equation 2 again, I'll have x2 prime is equal to y prime prime. Is that not it? Because this one, I'm going to differentiate this again. I'll get y prime prime. So at this point, I will equate this to x3, x3. Okay, x3. So now I have my x3. So then I can say that my x3 is equal to y prime prime. This becomes my third equation. So let me say if I'm to label, I'll have this to be 1, 2, then 3 as well. Okay. So we continue by differentiating our third equation. That one, we get x3 prime should be equal to y prime prime prime. And that should be equal to x4. Okay. So x4. Therefore, I can say that my next equation is x4 is equal to y prime prime. So that is the third derivative. Okay. So once I have this done, then at this point, I'm not going to differentiate it again. Okay. This will be the last one. So now I'll have this. Um, so at this point, sorry, let me differentiate for the last one because we are doing fourth derivative. Okay, fourth. So this one is my third equation. Then my fourth equation simply becomes x4 prime is equal to y prime 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 prime. That is the fourth derivative appearing in the question. So with this one, I will simply go back to my equation, then express my y prime 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 in terms of the others. Okay, so here you realize that my x4 prime will be equal to, now I'm going to shift all these ones here, right, to the left side of the equation. So watch me clearly. I'm going to have negative 3 y prime prime, okay, minus, but the minus sign becomes plus here. Okay, plus sine of t y prime plus 8y is equal to, oh, sorry. So I have 8y, so that will be minus 8y. Okay, that will be minus 8y, minus 8y. So I have minus 8. Then I have already t squared is on the right side, so plus t squared. So realize that I have now developed four different equations. I have this to be my fifth equation. So I have equation 1, equation 2, equation 3, equation 4, equation 5. Right? Yeah. So there's five different equations. But now let's see. Looking at the initial conditions, we can get the values of our system. Is that not it? So let's see that one too. You realize that y of 0, we know that y is now x1 in our system. So if I want to replace y, I'll make it x1 of 0 to be equal to what? 1 accordingly. I'll have x2 of 0 be equal to 2. X3 of 0 representing y prime prime, as you can see clearly here, should be equal to 3. And finally, x4 of 0 will be equal to 4 because x4 here represents what? The third derivative as we have here. So we also count this as different, equation, but this corresponds to this. So all this equation will correspond to what? This ideally. Okay, good. So now we have these pieces of equations. So let's put them together following the initial general form I showed you. Right? This is the initial form. This is what we want to achieve, right? So let's do that. So this one here is a vector of all the different first order terms you are looking for. Okay, you can set 1 prime, x2 prime, x3 prime, and x4 prime. These are the broken. It was initially fourth order, but now we have broken down into four different first order. That's the idea behind this method. Okay, so with this, we simply have the four different here on my left side. So that's going to give me something. Okay, so I have this side of the equation giving me x1 prime, x2 prime, x3 prime, x4 prime in one system like this. Okay, so that's why I introduced the vector sign here. So this should be equal to my coefficient matrix. So my coefficient matrix here will have to do with all the, these are the equations here. So we'll have to do with the respective equalities. So let's see. Now, remember that my x1 prime was equal to what? X2. Is that not it? So here becomes what? X2. My x2 prime becomes what? x2 prime, x3. Then my x3 prime became x4. Is that not it? And my x4 became what? This whole equation, which is negative 3y prime prime plus sine of t y prime minus 8y plus t squared. Okay. So this is my coefficient matrix here. And remember, it is multiplying a set of what? X. That's what you should take note of. Right? And those set of X is the x1, x2, x3, then x4. Okay. And this should be equal to um let me see, I have plus g of t, right? So plus of g of t. So let's do that one here. That's gonna make it so easy. So that is our non-homogeneous term. Okay. So let's see something here. So this is what I'm going to do. So the t that you find here, right? I'm going to take it off. But remember that we are now dealing in x. We are not dealing in y. So I've got to correct this side. Okay. So I'm going to clean everything. Wherever I see y, it should be x because we are in the x dimension. So when I come here, my equation is negative 3y prime prime, right? So let me start from the smallest. I have 8y. So that will become negative 8. Y is what? X. X1, right? So negative 8 x1 nicely. Then I'll come to my next higher, which is y prime. So I'll have plus sine of t. We have x2 nicely for the y prime. Then we have the y prime prime minus 3, right? Y prime prime becomes what? X3. Then right now, what is left? We have t squared. T squared will not have any place there because it is a non-homogeneous term. It has got nothing to do with y. It's standing there alone. So this term makes our whole differential equation non-homogeneous differential equation. So that one is isolated as a whole vector on its own. Okay. So I'll simply add plus. Then the non-homogeneous term adds up to only our last equation. So I have 0, 0, 0 squared. Nicely like this. So this is the first step for us converting our higher order into a system of first order. Now let's finally conclude. Remember that we found out that our x1 prime of 0 is equal to 1, 2, 3, 4. These are the respective solutions that we are equating whatever we have here to. So that will sum it up for us. So I'll have my equation here. So if here is x2, meaning that the x1 component is 0, the x3 component is 0, and the x4 component is 0. Is that not it? Yes. So you redraw, then you have 0, right? Then you have your x2 coming, right? So let's say that will be what? X2, right? So I'll have x2, only x2 is standing there, so I can put 1 here. Then x3 is 0. My x4 is what? 0. Is that not it? When I come to the second part, it's only x3, so 0, 0, 1, 0. My x4 part 0, 0, 0, 1. Then this part, now I have negative, and then there. My x2, I have sine of t. Then my x3, I have negative 3. My x4 is 0. Then this should add up. So this one times my x1, x2, x3. So we are just trying to find the augmented matrix. Okay, augmented matrix of the system. I'll have my x1 here, x2, x3, then x4. I'll close it. Then I'll add this to my non-homogeneous term, which is 0, 0, 0 t squared. And this should give me 1, 2, 3, 4, according to my system as I did here. So nicely done. We've been able to convert our system, which was initially, yeah. So let's check the question. You realize that initially we have y to the power 4, and we are supposed to simplify this, which is going to be a hell. So systems of equation enable the simplification of any. It could be y to the power 10, 20, 30. Once you're able to simplify it into a system of first order equation, using some simple algorithms, you can simply find the respective what values of your unknown, and you'll be able to solve any system which is ordinary differential equation using the systems of equation. So that's all I have for you in this particular question, and I hope you understood everything clearly. Please, at this point, if you still haven't subscribed, I really would entreat you to do so. So support us. We move to the second problem. Okay, I have an interesting problem here. Good. So this is an application of a first order differential equation. We are doing just random problem solving. Okay, so you're not necessarily solving like higher order or second order. So I just caught up on this problem, which you have to do. Okay, so I don't know if you can see my problem so well. Enlarge it. So, oh, good. Okay, good. So let's read it together, deduce the necessary information, and solve it accordingly. Right. A fish population in a lake grows at a rate proportional to its current size. First preamble. Without outside factors, the fish population doubles in 10 days. However, each day, 5 fish migrate into the area. 16 are caught by fishermen and 7 die of natural causes. Determine if the population will survive over time, and if not, when the population become extinct. The initial population is 200 fish, as simple as that. So you are to model this as a differential equation, then also find the estimated time only if you think the population will go on extinction, right? So if it will go on extinction, at what time do you think this population will die? They migrate there, but look at fishermen is catching like 16 every day, while 7 of them too are dying of natural causes. So balancing this system, we can model this as a differential equation and solve. So that is one application of differential equation which you are going to tackle. Yeah, so please take note to your seat, get your notebook, make sure you solve accordingly and you write accordingly as you solve it. So what's the first step in solving this problem? Solution. So to solve this problem, we first need to write our general model. So see something here. You realize that for any population, for you to measure the survival or the death, you realize that if you have the P over the T, that is the change in population with respect to time, is equal to the quantity of fish right inside now minus the quantity of fish which goes out of the population. That's all. Like generally, this is what we can say, that if I want to know the change of population with respect to time, is the fish in minus the fish out. That will give me the instantaneous, or let's say my total number of fish I have at any time. Is that not it? So this is the general model. Once you have this model down, we come to look out for our parameters. How many fish come inside and how many fish go outside, right? So my dp over dt will be equal to, for my r in, I'll come here, see something. A fish population in the lake grows at a rate proportional to its current size. That is saying that the rate of growth of the fish is proportional to its current size. Okay, that one is a whole differential equation on its own. It's saying that the p over the t, right, is proportional to what? P naught, its current size, right? Therefore, I can remove my proportionality and replace it with what? A constant of proportionality, right? This sign, I will just make it the p over the t is equal to an unknown r times my p naught. This alone is a whole differential equation on its own. I'm not interested in this because I already have my dp over dt. So what do I get? I have my r p naught satisfying the first condition. He said without outside factors, the fish population doubles in 10 days. That is also another condition back in this, that assuming that there is no other factor, then my fish population is going to double. My fish population is going to do what? Double, right? So I'll have in 10 days my fish will what? Double. So let's put this one down. We come back to it later. Now handling this one, he says that, however, 5 fish migrate into the area. So meaning our population will increase by 5. This is for the Rn. So my Rn is simply my first point of growth plus the 5. So originally it's gonna grow. They are saying that it grows at a rate proportional to its current size, whether somebody is coming in or not, because fish. Then the plus 5 is the external fish that will come inside. Then minus Now, with the fish going outside, you can see that the fishermen come to catch 16 every day. So 16. Already seven people die. I'm sorry, seven fish die. So I'll add seven. So these are my outgone fish. So the P over the T then becomes RP naught plus 5 minus what? So 23. That not it. The P over the T simply becomes RP naught. 5 minus 23 is negative 18. And this is a perfect differential equation. But before we can solve this differential equation, remember we need to find a value here, which is R. Is that not it? Yes, which is R. So let's get rid of that R and see how best we can solve this problem. We can get rid of this R by solving our first differential equation, which is the P over dt is equal to RP naught. Okay, the P over dt is equal to my RP naught. And the condition is that it doubles after every 10 days. Whilst they told us that the initial fish is 200, meaning that after 10 days, so after T is equal to 10 days, I'll have my fish population to be equal to 400. And at T equals 0, my fish population is equal to 200. So as we're about to solve this. So now, this that we have here, right? So if you want to solve this problem, what do we have? So let's try and simplify this expression here. So my P here, I'll simply cross multiply. This is a simple separable. So the P, right, over R, right, is equal to the T. Oh no. So I'll simply have this side. So I'll have the P here multiplying 1 over equal to R, right. So here, what do I have? If I integrate both sides, I'm going to have integral 1 over P not P equal to integral R dt. I'll have ln P naught is equal to my RT. It becomes RT. Okay, RT. Then RT to have here, I'll have my P naught to be equal to e to the power what? I'll have e to the power what? RT. Cannot it? E to the power RT. So here I didn't add a constant of proportionality. So let me add a constant of proportionality. So I'll have my ln P naught is equal to my RT here plus, let's say, C. So here I'll have my RT plus C top here. Make sure it doesn't confuse RT plus C. And remember that if you have P is equal to um this, I can decompose and I have e to the power C multiplying e to the power RT. Okay. And this becomes P is equal to C e to the power RT like this. So this is simply our model differential equation. But you know that the C here is just a constant of proportionality, and at time t equals 0, we had our initial population P naught, right? So I'll say that my P naught here, which is P naught, right, will be equal to C multiplying e to the power R times 0. So everything here will be 1. So I'll have C to be equal to P naught. You let me do it systematically so that you see. So 0 times R is 0. E to the power 0 becomes 1. Therefore, our P naught becomes equal to C, right? Yeah, so therefore, my differential equation becomes P is equal to my P naught e to the power RT, so that your population at any time is equal to your original population, multiplying an exponential function to the power RT, right? Where T is the time and R is a constant which we've got no knowledge about. So let's put this one down. And at this point, we can simply find the value of R. Our interest is finding the value of R to go and solve the original differential equation we have here. So this is actually our original differential equation, but we need R before we can come and solve. Okay, that is why we are doing that. So now let's find R here. We can use the conditions attached to our problem, which says that if at population at it doubles. So let's go back to the problem and check. He said that the fish population in a lake, right, without outside factors, the fish population doubles in 10 days. So meaning that since the initial population of the fish as written in the question is 200 here, right? So after 10 years, I'm going to have 400 fish in this population. So at t is equal to 0, I think I've written them here, so I didn't know. And that was simple. So here, I'll have my p of 10, right? P of 10 to be equal to 400. So when I come here, I'll have my original p naught to be equal to what? 200. And this one is, so let me write this very well. So let's see something here. If you have 200 e to the power 10r, you know p naught is original, right? It's original. After 10 times t, we should get 400, right? So at time t, right, we should get 400. So my p is 400. When I make this substitution, so it's a p of 10, that is at time t equals 10. I simply replace my t with 10, and that's what I've done here. R is equal to 400. That's my p is equal to 400. So we can use this to find the value of what r. Is that not it? So let's see what I'm going to do here. I'll have my e to the power 10 r is equal to 400 over 200, and obviously you can see it's 2, right? So e to the power 10 r is equal to 2. What do? I take ln on both sides. So ln, whatever I have here, equal to ln of 2, and therefore I'll simply have 10r to be equal to ln 2. Then my r is simply ln 2 over 10. R is equal to ln 2 over 10, and that's we are done. So since we find the value of r, let's come back to our initial differential equation that we have here. So we continue with solving this. So the p over dt is equal to r multiplying p naught minus 18. That's the differential equation that we have. Okay, so let me solve that. So the p over dt, right, equal to r p naught. R is now equal to, you see, because you're going to solve a differential equation, there's no need for us to make it p naught. The p naught and the p is just trying to distinguish or make a labeling here that we have an initial population. But if you want to solve differential equation, they should be uniform, right? It shouldn't cause any trouble here. Minus 18. So now this is what you have to tackle. What type of differential equation is it, and how do we approach? This is our goal. So this is a perfect linear differential equation. Let's express it. So I'll have my differential equation in its standard form as dp over dt minus ln 2 over 10 multiplying p is equal to negative 8. So this has been expressed in the form dy, let's say dy over dt, right, plus p of t multiplying hot y is equal to g of t. And this is the perfect linear differential equation. All that we need to do is to find our integrating factor mu here, right? So our integrating factor mu of t, or whatever, is equal to e to the power integral of the coefficient of p. Now, coefficient of p is what? Negative ln 2 over 10 multiplying p. So here, my answer becomes what? When I'm to integrate this expression here with respect to the t. Oh, sorry, I introduced the p. I'll clean this. So if you are to integrate this with respect to the t, I'll simply get e to the power negative ln 2 over 10 t. That's all. This becomes my integrating factor. Whenever you want to simplify your linear differential equation, remember that you multiply your equation through by your integrating factor. I'm going to have e to the power negative ln 2 over 10 multiplying t. All this times dp over dt, right? Then minus ln 2 over 10 p multiplied by e to the power negative ln 2 over 10 is equal to negative 18 multiplying e to the power negative ln 2 over 10 t. You know, this is a little bit bulky, lengthy. Yes, that's the nature of differential equation. So kindly follow closely so that I don't get lost at any. So here, the rule says that you always break this one down and it will become p multiplying your integrating factor negative ln 2 over 10 multiplying t, and this should be equal to the, so all this one into bracket prime Yeah, is equal to negative 18 multiplying e to the power negative ln 2 over 10 like this. Then what do? I take integral on both sides to eliminate my derivative sign here. So there's derivative sign here goes away with my integral. Then I simply get my p multiplying e to the power negative ln 2 over 10 t to be equal to integral of the expression negative 18 e to the power negative ln 2 over 10. Now let's do this simple and nice integration here. So with this expression, I only have to make this side I'm done. I only have to divide through. So how do I differentiate this? Every constant will move out of our integral sign, right? So negative 18 goes out, integral e to the power negative ln 2 over 10 t. To integrate this expression, remember that you will take the coefficient of t here and divide it by the system. I'm not here to teach integration. We are solving differential equations. So I hope by now you understand this. I'll just move straight. I'll have negative 18 times what? 10 over ln 2. That is negative. Remember when I divided by the system, it was some sort or two. Change over. Yeah, that's pure mathematics. And I'll have my expression e to the power negative ln 2 over 10t back again plus c. So now at this point that I have this expression, remember what I'm going to do. I'll simply what expand here and divide through by what this. So my p then becomes, I'm going to divide through by this expression, but I already have this become negative. Let me make it negative 1 8 over ln 2. Okay, e to the power negative ln 2 t over 10 plus c. Then they remember the c here too. I'm expanding. Okay, I'm expanding. C times of negative, but in differential equation, when you multiply anything by c, it becomes c. It becomes c, unless that thing is a function. If you multiply a constant by c, let's say you have c, you say 2 times c, 2 plus a is 2c. The thing is unknown constant, so there is no need for you to say that 2c. So just make it c, everything becomes unknown. Okay, so you know that already. Actually, we're supposed to have multiplied this by c, but this is a constant. Times c is still c. It doesn't change. Okay, so we're gonna have c here, right? And everything I have here will be divided by the coefficient of my p, which is 1 over e to the power negative ln 2 over 10t. And from here, you can clearly see that this will come and cancel this, and I'll have my p to be equal to negative 18, 180 over ln 2, standing there alone because this will go away, plus c. Now, because I'm saying that because c here is a constant and this is a function, it wouldn't change it to c. It's a function. You don't do anything to it, so it will become positive ln 2 over 10t because it's negative here, multiply, right? You should understand. So now this is the end of our solution to our differential equation, but we are still not there yet. Remember the question asked us that, do you think the population will go on extinction? If yes, at what time will the population go on extinction? Now, we've been able to successfully express our population in this differential form. We still have to get rid of the c. Without getting rid of the c, we are still not done. So how do we get rid of the c? Remember, we still use our initial condition that initially there are what 200 fish. So wherever I see t, I put what 0. As simple as that. I'll have sorry. So I'll simply have b to be equal to negative 180 over ln, okay, plus c e to the power ln 2 over 10. My t now becomes 0. So this becomes 200 is equal to negative 8 180 over ln 2. Okay, then this becomes everything here becomes 0 1. So I have plus c. So what is my c? C then becomes 200 plus 180 over ln. We put that into the calculator and let's see what you are getting. So I'll simply have 200 plus the expression 180, right? Is it still negative or should be positive? So I think that when you reach this point, we had negative times negative that gave birth to positive here. So there should be positive sign here. Hope I don't get lost. Should be positive sign here. And I should have a positive sign here. Positive. Good. So I have 180 going into the positive sign still. Okay. 180 going over lane 2, right? Then what am I? Having on a half times. Okay, okay. So meaning that this side, if this is positive, then my C here will take this there, right? So it's going to be subtracting here, right? I'm not going to add. Take something. Here is positive. So when I put 0 here, everything here becomes 1. So to find C, C becomes P minus 180 over lane 2. Good. So I just take this out. Nice. And positive. So my C then becomes go away. Then this becomes my. So I have 200 minus 180 over lane 2. Good. So you rather make it 200 minus expression of 180 over natural log of 2. So negative 59. So my P, which is my population, then becomes 180 over length, right? Yeah. Minus 59.6. Good. So length 2 minus 59.685, right? So let's make it 6 9. Then e to the power link 2 over 10. That's all. So from the question, let's go back and see something. The question asked that determine if the population will survive over time. If not, when will the population go on extinction? So meaning that at this point that we have our general modeled equation for our population, we can ask that when would this p become 0? That is the goal. So if p becomes 0, at what time? Good. So let me put 0 here. So 0 is equal to 180 over length 2 minus 59.69 e to the power length of 2 over 10t. Okay, so at this point, what do I do? I carry this there, 9.69 e to the power length 2 over 10, which I'm looking for t equal to 180 over. So what do I do? For me to solve this, I need to divide through by 59.6. So e to the power length 2 over 10t will be equal to 180 over length 2 divided by what? 59.6. So let's solve this and put the value there. So I have 180 over length 2, right, divided by 59.6. That is 4.35. I have 4 point, so e to the power length 2 over 10t equal to 4.35. What do I do? Nicely, I can take lane on both sides, right? I'll have lane A, and that lane A will give me lane 2 over 10t, which I have here. Remember, if I take lane, it will be equal to lane 4.35. That's not it. Then at this point, I can divide through by what? Lane 2 over 10. So my t is simply equal to lane 4.35 over lane 2 over 10. Then what do I get? That becomes 9. So natural log of 4.35 over lane natural log of 2 over 10, which is also 0.5, right? So 2 over 10 is 0.4. No, 0.4. So sorry. That's too simple. Right. Oh, interesting. Get it. The power My God. Yes, yes, yes. So I made a mistake. It is lane 2 all over 10. I'm making it lane of the expression. So my inscription made me get that wrong. So lane 2, the whole lane 2 over 10. Okay. So it's like this. Lane 2 over 10. So I made a mistake from here when I was writing this over 10, because that is exactly what you have been doing. So it's lane over 10. So when I was writing, I made it right. So lane 2 over 10. So let's do it well. Meaning that this over 10 will multiply by what I have at top, right? So it becomes t is equal to 10 times length 4.35 over length. This is how it's supposed to be. So 10 times the expression length 4.35 over length 2, and that is 21.1. So my time is equal to 21.21 and years, right? So to take 21.21 for the fish in the pond, or for the whole population to go on an extinction. And that is how this differential equation solves. So that is all I have for this particular problem. And at this point, if you have still not subscribed, please, I want you to subscribe to support and stay with us as we move on with the different problems in this lesson. So let's go to the third problem. Okay, good. So I have one beautiful problem here on this. I hope you can really. Okay, so we are supposed to use Laplace to solve this differential equation. So using Laplace, we are supposed to find the solution to the second order differential equation we have here. So the question's a little bit bulky, so we wouldn't be able to solve so much, but I, I hope it's been helpful. Okay, so using Laplace, you are supposed to solve this. So you know Laplace, right? When you talk about Laplace transform, okay, the idea is that if I have e to the power, not let me use if I have 2 to the power x, right, plus let's say 20 equal to let's say plus 20x is equal to 5. For us to solve this problem, we need to get x down. And for us to get x down, what do? We introduce a function called natural log. And what this natural log or logarithm does is it's able to help us compute power of, I mean, without that, you cannot actually compute this power. And that is similarly what Laplace seeks to do. So Laplace is actually an integration function, or I would say an integral function, which seeks to simplify or convert every function we have here into that realm. And after simplifying, we reverse it back to this. Okay. So if you are to model this as a signal, you try to simplify this into the frequency domain, right? And you let me go straight to the point. I don't know. Take this after. Yeah. Oh, solution. So the first step into simplifying this using Laplace, I write my differential equation ny prime plus 9y is equal to 5t. My initial condition y of 0 is equal to negative, y prime of 0 is equal to 2. So what you are supposed to do is take Laplace of each and every component. That's the first thing to do. Okay, that's the first thing to do. So Laplace is actually represented as this L. So if you see this kind of L, it is simply saying that what the Laplace of that function f of t. So Laplace of a function f of t is also represented as capital L domain that we want. So this x is actually a customized s, which represents a complex plane. Okay, a complex plane, which is um a whole different concept on its own, but that is should be behind the scene. Let's simply use it to apply and solve this problem. So to solve this problem, I'll take Laplace of each component. So Laplace of y prime prime minus Laplace of 10, so minus Laplace of what 10y prime plus Laplace of 9y is equal to Laplace of 5t. This is the first step. So there is this general formula for if you want to find the Laplace of y prime prime, okay, generally is given as s squared y of s is a predefined term which we use. We have minus y s times y of 0. Let me clean it. So s times y of 0 minus y prime of 0. That is only for this, so Laplace of only y prime prime. So anywhere you see y prime prime and you want to solve it using Laplace transform, simply have to write this whole long thing. It's a template. You are not done, we go to the next one. Minus, now, please, we don't need the 10. Push the 10 outside. Yeah. So minus the 10 will go outside. Then it will come and multiply everything that we're going to do. So minus 10. Then Laplace of this y prime gives capital Y, right? We get capital sy of s. Remember that the y prime prime started as x squared y of x. We step down towards x y of 0. So here we have x y of x. We simply step down towards y of 0. Like that. So you can see that if you are to go further, it will give us what y prime prime of 0. But that will influence the power which we are dealing with. So once you've written this down, that is up to this alone. We are just here. So at this point, I can clean this and still continue. So wow. So if I have this expression down, I move to plus Laplace of 9y. Laplace of 9y. So here I can introduce the Laplace table, okay? So in the Laplace table, if you have 9y, which is, let's say, 9y will be something like a t, right? So please take notes. We have the customized or the predetermined Laplace form transforms. We have the y prime prime, y prime, and the y. Like it's a family, okay? It's a family. So here, if you want to find the Laplace transform of y, remember 9 is just a constant. Push it out of the Laplace, we get Laplace of y. What is Laplace of y? You just make it a capital Y of s. That's all. A capital Y s. That is all. So simply simplify. Then this should be equal to what's the Laplace of 5t? So from the Laplace table, you can go back to the Laplace table if you don't have such online Laplace table. And what is the Laplace of 5t? 5t. So generally, if you have any term t to the power n, where n is any positive integer, the Laplace transform is generally given as n factorial over s to the power n minus 1. N minus 1. Okay. Sorry, it should be x plus 1 rather. X plus 1. So n plus 1. So if here you know that the t here we have 5t, meaning t to the power 1. Therefore, t to the power 1, what do we get? 1 factorial is 1. And what is Sn? We get s squared. Is that not it? The constant here is 5. Therefore, my answer is 5 over t and 5 over s squared. And plus that. Yes, so let's make the necessary substitution here before we proceed. You remember that y of 0 is given as what? Negative 1. Y prime of 0 is given as 2. So let's make that quick. So s squared y of s minus x times y of 0. So y of 0 is negative x, right? It's already negative 1, so this becomes positive s minus my y prime of 0 is 2. So I simply have 2 here minus 10 multiplying s times y of s minus my y of 0 again, which is negative 1, becomes plus 1 plus 9 ys, right? Is equal to 5 over squared. At this point, what do we want to achieve? At this point, we only have to factorize y of x. That's all. So we want to put y of s all into 1. So to find y of s quickly, Um, let me see if there is a need for expansion or simplification further again. Yeah. So let's see. This y of x stands out. Y of x. A bigger bracket is open. I can see I have x squared here nicely, right? What do I have? This one you are not part. I'll come here. You are also here. So I have negative what? 10 sys, right? So I have negative 10s. Is that not it? Yes, I'm right. So I'm just trying to factorize y of s. So look at the equation. Wherever y of s is, I first should have grouped